chapters. So the first chapter, that is A1, how can the motion of a body be described quantitatively and qualitatively. So we have started with kinematics, which is basically the study of motion. The first thing that I would tell you, that if you have to imagine what gradient is, you just keep in mind it's just like slope. So that is the basic definition of speed. Speed of any object indicates the distance traveled per unit time. Hello students, in today's class we will discuss about acceleration. But before we start with today's class, you should be remembering that we were discussing about the various parameters that we use to quantify motion. What were those parameters? Distance, displacement, speed, velocity and acceleration. So one by one we are talking about them. So we've discussed the first 4 parameters, and today's class will focus on the 5th parameter, which is acceleration. So whenever I use this word, or whenever I say this word acceleration, what do you have in mind? You might have an accelerator in your mind, in your car for example. So you can have that in your mind. So whenever you press the accelerator, that indicates that the car is going to speed up, right? In fact, when you apply brakes, you know that the car is going to slow down. In a way, both are acceleration, where either the speed is increasing or decreasing. You might have had an introduction of this in your previous classes, but again, just to have a start, what is acceleration? So when an object speeds up or slows down, whenever an object speeds up or slows down, then that is when you call an object is accelerating. So does that mean that there are 2 possible cases? First, when we had uniform motion, that is the speed was constant, then there was no acceleration. But now if the speed changes, either increases or decreases, then we call it acceleration, right? So what is acceleration? Please make a note of this, that whenever an object speeds up or slows down, it is said to be acceleration, okay, or it is said to be accelerating. Next, how much is the acceleration? So when I told you that when you press the accelerator, your car starts speeding up, how rapidly it is speeding up, that tells you the amount of acceleration. So in simple terms, acceleration is nothing but the rate of change of velocity. It is the rate of change of velocity, how velocity is changing, okay? You make a note of that as well, that mathematically or quantitatively, acceleration is the rate of change of velocity. Please use the word velocity and not speed. I will reveal why. So acceleration is not rate of change of speed, it is now rate of change of velocity. All right, so please make a note of this. Then again, let's quickly revise that we in the last class were discussing that every parameter will have 2 different components. One was the average and the other was the instantaneous. So one was the average and the other is the instantaneous. So whenever you want to see a bigger change, that is when you go for average. But whenever you want to see the change at that particular instant or that particular point, then you will go for the instantaneous. So acceleration will also have those 2 versions. There will be average acceleration and there will be instantaneous acceleration. So if I may put it like that, acceleration is basically change in velocity divided by the change in time. So if I am writing v final minus v initial upon time, then I am majorly talking about the average value. So what is acceleration? Change in velocity divided by change in time, that is delta v over delta t. I hope remember that delta indicates change. One more thing, if you are seeing here v by v, what we mean is the final velocity, okay, and u is generally used for initial velocity. So v indicates final velocity and u indicates initial velocity. So what is the average acceleration during the time velocity changes? So it is delta v divided by delta t, or delta v over delta t. Please make a note of this. Now, if I ask you how will things change if I talk about the instantaneous value of acceleration, the instantaneous value of acceleration, that is the acceleration at a particular instant, then you would say that acceleration is going to be in instantaneous form. So instantaneous acceleration. Okay, so what is that going to be? So that is going to be limit delta t tending to 0. So that is a very small interval of time. So we write limit delta t tending to 0, delta v over delta t, which in the very next step we may write as dv by dt. So acceleration is nothing but the differentiation of velocity with respect to time. This is the instantaneous value and this is the average value. We will talk about how this is incorporated graphically also, as we had an introduction in the last class, but that we'll do in the coming up classes. For now, acceleration is simply the rate of change of velocity. Of course, it is a vector quantity and its SI unit is going to be meter per second square, and you can understand why, because it is nothing but the ratio of velocity divided by time, or the ratio of velocity to the time. So it is meter per second over second, that makes it meter per second square. Meter per second, that is meter per second square. Next thing, just precisely if we are wanting to talk about an object speeding up, then we normally call it accelerating. So when you press the accelerator, then that is what you call as an accelerating object. But when you apply brakes, then you are basically decelerating, or it's called a retardation or deceleration. Okay, so keep that in mind also, this terminology, that whenever an object speeds up, it is said to be accelerating, and whenever an object slows down, it is said to be decelerating, or it is referred as retardation. Okay, one last thing before we move on to the next thing is that whenever, let's say let's say acceleration is 1.25 meter per second square, then how do you interpret that? So if let's assume that it's a uniform acceleration, it's a constant acceleration, then that would mean after every second the velocity is going to increase by 1.25. So let's say if we start with zero velocity, let's say initial velocity is 0, then after 1 second, so this is t0, then after 1 second the velocity will become 1.25. After another 1 second, so that is like 2 seconds, the velocity is going to become 2.5. Why? Because it further increases by 1.25. So please have that in mind, that whenever you see acceleration's value, that should tell you that that is the amount by which the velocity is going to change very next moment. But the problem again is that you cannot maintain the same acceleration. So it is like mostly even the value of acceleration keeps on going up and down. Very rarely you see acceleration to be uniform or constant. In fact, you have an idea about that. That is the case when you talk about motion under gravity, because under gravity the acceleration is constant in case you don't take into account the air resistance. So again, let's repeat, when acceleration is uniform, then you can say that velocity increases or decreases by that same amount every second. For example, for the case of gravity, for Earth, the value of gravity is 9.8 meter per second square, or approximately 10. Sometimes we also refer to that value depending on what is mentioned in the introduction or the question specifically. So acceleration due to the Earth is 9.8 meter per second square. So if I drop an object which is in, like, assuming that there is no air resistance, then every second its value of velocity will increase by 9.8 meter per second. So acceleration due to gravity is one common example of acceleration, and it is normally denoted by g. It is normally denoted by g. So this is 9.8 meter per second square, but that is for the case of Earth. Different planets will have different values of gravity. So for example, Moon, the gravity is 1.6 meter per second square, so it's almost like what is 1/6 of Earth's gravity. Different planets, so let's say Jupiter, that is the maximum gravity among all the planets. So Jupiter has a gravity of approximately 25 meter per second square, but don't worry, you don't need to memorize these values. So these values will be provided to you in the question. But for now, I just wanted to talk about what acceleration is. I hope it's refreshing your memories, and you have mostly talked about these things in the previous classes. One thing that you might be seeing here is another unit of acceleration, that is Newton per kg, and that is mainly because of the formula, that is the Newton's second law, which is F is equals to ma. So if you go by that logic, then the unit of acceleration can also be written as force upon mass, that is Newton per kg. So keep that in mind. This is all about the basics of acceleration. Average acceleration is delta v over delta t, but instantaneous acceleration is dv over dt, or differentiation of velocity with respect to time. Acceleration is the rate of change of velocity. I think we can move forward from here, but you can copy down anything if you want to. Alright, so now we move on to the next thing. Let's do a couple of numericals very quickly, which are very basic, but that will give you a feel of how to use acceleration in real life situations. So we have a situation here where a car is accelerating from 10 meter per second to 35 meter per second, and it takes 5 seconds to do that. So can we start with the solution straight away? Just first let's summarize what are the values given. So initial velocity that we normally denote by u is given by 10 meter per second, okay, while final velocity is given to be 35 meter per second, and they are asking that what is the value of acceleration if this speed change or velocity change is achieved in 5 seconds. So shall we use acceleration is change in velocity divided by time? So that is going to be 35 minus 10 divided by 5. So that is going to give us a value of 5 meter per second square. That is the value of acceleration. So again, we are assuming that the acceleration remains uniform throughout the journey. So this is again something that we will talk about one by one, but for now we are assuming that acceleration is uniform. Secondly, what is the second part of the problem? Find its speed after 10 seconds. So we are using this acceleration and predicting speed after 10 seconds. So we will again use the formula that acceleration is equals to v minus u over t, and now we put the value of acceleration, which is 5. So we are starting with the second part. Acceleration is 5. Final velocity is what we have to find out. Initial velocity is 10, and the time is this time 10 seconds. So this time the time is 10 seconds. So what do we get from here? If we multiply this on the other side, so this will give us 5 times 10 is equals to v minus 10, or v is equals to 60 meters per second. V is equals to 60 meters per second. So we have used the value of acceleration to get the value of final velocity. Similarly, the third part of the problem, what is that? Find the time after which its speed becomes 70 meter per second. So they've given us the acceleration and they are wanting us to tell or find out what how much time it will take to achieve that speed. So we shall again write acceleration is 5 and final velocity is 70, initial velocity is 10, and this time the unknown value is time. So we are plugging in all the values except for time because we don't know time for this part. Alright, so what do we get? T is equals to 60 divided by 5, that is 12 seconds. So now we again we can remember how we used to have questions of acceleration, but these are very basic questions. Okay, we have another problem here. A ball is dropped such that it falls under gravity. So it's under gravity. Ignore air resistance. So we are looking for this word for now, that we have to ignore air resistance. Find the speed at the end of 5 seconds. So I think we can start, and we shall write v minus u over t. Now, one thing that I want to again remind you, that we are going to follow a particular sign convention. What is that sign convention? That for x direction, we will take rightward as positive and leftward as negative. Okay, for x direction, we are going to take rightward as positive and leftward as negative. For y direction, we are going to take upward as positive and downward as negative. So this is the convention we will try to stick to most of the time. So if we follow that carefully, let's see, carefully, we put the value of acceleration as negative 9.8. Why do we do that? Because gravity is acting in the downward direction. So let's put the value of acceleration due to gravity as negative 9.8. V is what we have to find out. Okay, and u is 0. Now why is u 0? Because there is a term used here that a ball is dropped. Okay, a ball is dropped, and if nothing is mentioned, we will like to assume that it is dropped from a stationary frame. And if it is dropped from a stationary frame, then initial velocity has to be taken as 0. Okay, and the time is how much? So time is given to be 5 seconds. So value of v turns out to be a negative of 9.8 times 5. So that is going to be a negative of 49 meter per second. So what is this indicating? That velocity is negative. That means it is going in the downward direction. But since they are asking speed, so keep that in mind. We will never give the answer with a negative sign. So speed answer is going to be plus 49 only. So we will not put a minus sign here. But do keep it in mind that we will always follow things using this sign convention. So whenever we start with and start plugging in the values, be careful that you put them with the proper sign. Okay, you can copy this down and then we will move forward. All right. So next thing, in fact, I wish to talk about is that when I was saying that an object is speeding up or slowing down, only then it is said to be accelerating. Actually, that's not 100% true. How? Let's take an example. Let's take a very basic example. Let's say there is a circle, okay, and an object is moving with a uniform speed. Let's say that uniform speed is 10 meter per second. Okay, so it was, let's say, initially here. So circle is something that we all can relate with. So initially it was at position A, okay, and its velocity was 10 meter per second, and the direction obviously will be towards north. Now let's say after 2 seconds it reaches this point B, where its velocity becomes 10 meter per second, but now the direction is towards east or towards right. So it was up and now it is right. So can we say that this velocity and this velocity are the same? The answer is going to be no. This velocity and this velocity are not same. The speed might be same, but the velocity is not the same because it has changed the direction. So let's say it started off here at t0 and it reached here at t2 seconds. So can we say that it has accelerated? The answer is going to be yes. It is accelerated since the velocity has changed. So what is the initial velocity? This is the initial velocity. What is the final velocity? So this is the final velocity. Now what is the expression for acceleration? So now we will include the vector component as well. So this is going to be v final minus v initial divided by the time. So we are calculating the average acceleration. We are calculating the average acceleration from 0 to 2 seconds. Average acceleration from 0 to 2 seconds. So what is the final velocity? It is this. What is the initial velocity? It is this. So what is v final? So you will denote it by a vector like this. Okay. What is v initial? You will denote it by a vector like this. So both these vectors are equal. Why? Because the magnitude is still equal. But what has changed is the direction. Now, if I say this is 10 and this is also 10, so do remember that whenever we had to subtract vectors, what does minus indicate? That the direction has reversed. So we had talked about it. So can we say that this can be written as v final plus minus v initial? So it is going to be v final plus minus v initial. Can we write it like that? So where is the v final vector? It is this. Be very careful. And what is the minus v initial vector? It is going to be this. Why? Because I have switched the direction. So if this was v initial, then this is representing minus v initial. And what is the net acceleration, or what is the v final minus v initial? So we are adding these two. So if you remember how vectors were dealt, how they were added, then you would know that the addition of these two, that is delta v, is going to be under root of 10 square plus 10 square. Or you can also draw the diagram to the scale, and then you can also measure the length of this diagonal. Or you can use the Pythagoras theorem, where this is also 10 and this is also 10. So you can understand that it's going to be how much? Under root of 10 square plus 10 square. That is going to be 10 root 2. So what is the acceleration now? So the acceleration is going to be 10 root 2. That is the change in velocity divided by the time. Okay. So time is 2 seconds. So it is 5 into root 2. That is 5 into 1.4. So that is going to be approximately 7 meters per second. That's approximately going to be 7 meter per second square. And the direction is going to be, since this is east and this is south, so the direction is going to be somewhere along southeast, since these are equal. So this is also 45 degree. Okay, so let's again revise this, because we did not deal much with vectors in the previous classes. So this is something new for us, that we are seeing a case of acceleration even when the body is not speeding up or slowing down. So there is no speeding up, there is no slowing down. It is moving with a uniform speed. Even then it can be a case of acceleration. Can you understand now why? So acceleration occurs whenever, we will now say, whenever velocity changes. So here speed is not changing, but velocity is changing because direction is changing. Please make a note of this, and then we move forward. Okay, so now we will talk about equations of motion. So you might have heard of equations of motion in your previous classes. Maybe you don't know them at all. So that's perfectly all right. We are starting from scratch. We are discussing the equations right from the fundamental. So as the name implies, we are discussing equations of motion. These are going to be the equations that will relate the various parameters of motion. So what are the parameters of motion? Of course, you know them: S, U, V, A and T. So yes, of course, they are distance, speed, displacement, velocity and acceleration. But here these equations do not relate distance and speed. They are about relating displacement, velocity and acceleration. So what are the various things? S is the displacement, U represents initial velocity, V represents final velocity, A is the acceleration, and T is time. So when I say A is the acceleration, keep in mind that these are valid only for uniform acceleration. So these equations are valid only for uniform acceleration. These are valid only for uniform acceleration. For changing acceleration, these equations cannot be applied, but they are very useful. Let's talk about them one by one. But before we start, you can clearly see a situation where at t is equals to 0, there is a person, there is a cyclist who's moving with a velocity u. Now again reminding, t is equals to 0 does not mean when the motion starts. T is equals to 0 means when the observation starts. When the observation starts. So t is equals to 0 is the instant when the observer will see this person for the first time. Okay, he might have a velocity at that point, and let's call that velocity as u. In time t, after accelerating, it reaches a velocity v, and during this time it is displaced by s. Okay, so the first equation is obviously relating the final velocity, initial velocity, acceleration and time, which is nothing but the definition of acceleration, which is change in velocity over time. So it's going to be v minus u over t. So this can be rewritten as this. So v is equals to u plus at. I don't see any problem here. This is an equation which all of you can easily relate with, but this equation will be used only when you have to predict the velocity. It's not relating the displacement. So you can predict velocity at a later time, but not displacement. For displacement, we have the second equation. Now the problem is that since it is accelerating, velocity is ever changing. So if we want to write that average velocity is the displacement over time, average velocity is the displacement over time. So for this case, you can take the average velocity as the initial velocity plus final velocity over 2. That is the mean. That is the mean of the initial and the final velocity. But you cannot do that every time. Keep that in mind. You cannot do that every time. This is only applicable when you have a case of uniform acceleration. Only for the case of uniform acceleration. So what is average velocity? It is the initial velocity plus final velocity divided by time. So this makes it s is equals to u plus v over 2 into time. Some people also call this as an equation of motion. That is also fine. You can write displacement in terms of initial velocity, final velocity and time. So this is the average velocity into time, where average is initial plus final over 2. So mean of the two values. Now can we use the first equation again here? Can we use the first equation again? If we use that, then we can write v is equals to u plus at. Okay, v is equals to u plus at, and if we do so, then this becomes s is equals to ut plus half at square. So this is an equation we are going to use when we are wanting to predict the final displacement and we are knowing the initial velocity and the acceleration. So do keep them in mind. The third equation is, you can clearly see, time independent. So this is an equation that we are going to use when we have to predict a velocity after the body has traveled a certain distance. So if that happens, can we write acceleration as v minus u over t? Of course, that is the definition of acceleration. Now displacement was average velocity into time. So now we have to eliminate time. So we will use this equation to rewrite time, how can we do that? Time can be written as v minus u over a. Time can be written as v minus u over a. So in that case, displacement can be rewritten as v minus u over a. So that makes it 2as is equals to v square minus u square. 2as is equals to v square minus u square, which can be rewritten as this. So this equation will be useful when there is no information of time. So keep these equations in mind. They can give you very quick results. We can see how by taking an example, but you can copy this down if you want to. Otherwise, you can also pause the video and do that. Alright, so one simple example using all these three equations. So the first equation, we have a very simple example. An object starts with a speed of 10 meters per second, accelerates uniformly, and then we have to find its speed at the end of 4 seconds. So there's no problem. We are going to use, let's say, v we have to find out, then u is how much? U is 10. So we are just plugging in the values. It's not a big deal, just to give you a feel of it. A is how much? A is 2 and T is 4. So U is 10, A is 2 and T is 4. So the velocity at the end of 4 seconds turns out to be 18 meters per second. Secondly, an object is dropped from rest, then find the height through which it will fall in the next 2 seconds. Okay, so again, since they are asking the height through which it will fall, so it is talking about displacement. Secondly, it is dropped from rest, so u will be taken as 0. So s is equals to 0 times 2 plus a is going to be a negative of 9.8, and you know why? Because gravity is downward. T square is going to be 2 square. So s will turn out to be minus 19.6. So displacement is minus, means it is falling. So height through which it will fall, answer is going to be 19.6. Third question. Third question is that a car is moving initially with a speed, so this is the value of u, is brought to rest by applying brakes. So now this is a case of deceleration. So let's assume that the car is going towards right, and deceleration would mean acceleration towards left. That is when it will slow down. So acceleration value we will put as minus 2 this time, while initial velocity is going to be 20 meters per second. We have to find the stopping distance. We have to find the distance the car will take to stop. So since the car has to stop, final velocity is going to be 0. So we will plug in the values. 0 square is equals to 20 square plus 2. A is going to be a negative 2 times s. So the value of s will turn out to be 400 upon 4. So that is going to be 100 meter. So it will move further by 100 meter before it comes to a halt. So I hope you are now able to relate with these equations by taking these simple examples. I just want to take one more example to explain it even better, but you can copy this down before we move on to that example. So the idea is to understand how acceleration's value has to be used. So let's say if I tell you there is a ball, we throw it upwards with a speed of 20 meters per second. So I have this ball, and let's say I throw it upwards with a speed of 20 meters per second. Okay, so two things that I want to remind: ignore air resistance first. Ignore air resistance. Second, let's say, just for our calculation convenience, let's take the value of gravity as 10 meters per second square. Instead of 9.8, we are taking it as 10. Okay, so this is point A. This will go up and then it will come down again. Okay, so let's say this is the point where it reaches the maximum height, and it is the point where it ultimately falls on the ground again. So what are we wanting to answer here? So first, find maximum height. Find maximum height attained by the ball. So let's do that first. Okay, so that's the first thing that we want to talk about. Find the maximum height attained. So are we wanting to go from A to B? Yes. Why? Because we are only talking about the point it reaches the maximum height. So let's say it started off here, t is equals to 0, and this is where it reached the maximum height. So do you understand that when it reaches the maximum height, it will come to an instantaneous rest. So if you remember the first class, we had said that rest is a situation where position of an object does not change. So rest, you would always assume that something is stationary, like I am stationary right now, I'm not moving. So this is rest. But there is another type of rest, which is the instantaneous rest that you see at point B, because at point B it suddenly is from rather going up, it starts descending. So B is a point where it takes a U-turn, So can we say, because it is taking a U-turn, its final velocity at B is going to be 0, because it is becoming negative after that. So can we say A to B velocity is positive while B to C velocity is negative? Why are we saying that? Because we will always assume that upward direction is positive. You can pause the video, I will wait. Try to find out the maximum height. Think of it, which equation you should use here. So I think you should be very clear now that the best choice of equation here should be v square is equals to u square plus 2as. The third equation, since it does not involve time, final velocity will plug in the value as 0, initial velocity is 20, a is going to be a negative 10. Now why a negative 10? Because gravity is acting in the downward direction, and let's say the displacement is s. So are you following this, that we are using an equation and we are also mentioning which 2 points we are taking as initial and final? So A is initial and B is final. So the displacement turns out to be 400 divided by 20, so that's going to be 20 itself. So that is the height also. That is the height. Why? Because it's the displacement from A to B, that is the ground to the highest point. Okay, so that gives you an idea. We can also, calculate the time. Let's say that is the second part we want to answer. The total time of journey, the total time of let's say flight. What term can we use? Total time of flight. For what time was it in air? So you would say it started off at A and it landed back on ground at C. So this is the time for which it was in air. We are ignoring air resistance though. It is in like space. Okay. So what do you have to say? From A to C, can you understand the displacement is going to be 0? Because you started off at A and then you came back. Agreed, this is another point I am labeling C, but A and C are the same points basically. So displacement is 0 and we have to find the time. Time is what we have to find out. Initial velocity is known. Now you have to again take a guess or take a decision which equation would be suitable. Acceleration is going to be a negative 10. So some might be wondering that when it is going up, it is slowing down. When it is coming back down, it is speeding up. Because in the previous classes, you might be going with the convention that if a body is speeding up, you take that as positive acceleration. If it is slowing down, you take it as negative acceleration. But now we will not follow that convention. We don't want to change the sign of acceleration in the middle of things. So we will always take downward as negative and upward as positive, regardless whether the body is going up or down. So S is equals to ut plus half at square is the right choice if you've made that choice. S is going to be 0, u is 20, t is what we want to find out, a is minus 10, t square. When you solve this equation, you'll get t 0 or 4 seconds. 0 or 4 seconds. So of course 0 is when it started, it was on ground, at ground level, and then again it was at ground when it is 4 seconds. So the answer should be 4 seconds. So that was my effort to explain acceleration to you, also the equations of motion. I hope you have understood most of it. You can always relook or re-watch the video and try to understand things again, but definitely more clarity will come as we will start doing the questions. So today we've discussed the basics. In the next class we will talk about many questions that involve all these concepts. But that's all for this video. Thank you. If you enjoyed this video, please don't forget to like, share and subscribe to our channel.